In this video, we are going to learn about the position and the nature of the image formed by the plane mirror, as well as later on we will discuss about the speed of light. So starting with a basic activity, we are going to understand about the position and the nature of the image. So this is the main aim. We will need some materials. So these materials are a plane mirror, a toy car and a white sheet paper. Now what you have to do is this: you have to place the mirror and you have to place the car in front of it. The car is the object for the mirror. Now you will see the image of the car forming in the mirror. Now what you have to do, just move the car forward. You will see that the image of the car also move forward. Now move the car behind. Now you will see that the image also moves backward in the mirror. So what is the conclusion? Here is this, that the distance of object from the mirror is equal to the distance of image behind the mirror. Next thing you must do here is this: take your white sheet and place it behind the mirror, means here, and observe, can you see any image there? No. Now keep the white paper in between the object and mirror. Can you see any image now on the white sheet? No. Why? Because we know that the real image can be obtained on any screen, but virtual image cannot be obtained on the screen, and here the plane mirror forms the virtual image. So this is our procedure required, that you have to place a plane mirror vertically on a table as we kept here. Keep a toy car in front of it. We kept the toy car in front of it, and mirror at a small distance from it. See its image in the mirror. Push the car slightly towards the mirror. The image of the car has also moved towards the mirror. Now move the toy car backward and observe its image. The image is also moving away from the mirror. Hold a sheet of white paper behind the plane mirror. Move it forward and backward. See whether the image of the car appears on the paper sheet. Again, hold the sheet in front of the mirror and move it backward and forward. Is the image of toy car appearing on paper now? So what is the observation and what is the conclusion? You will observe that the image does not appear on the paper at any position. This shows that the image formed by a plane mirror is the virtual image. Now let us conclude all the features of the image formed by the plane mirror. So first of all, the image is upright or erect because it is virtual. Same size as of the object. Image is formed as far behind the mirror as the object is in front of it, because we know that the distance of object from the mirror is equal to the distance of the image behind the mirror. The image is a virtual image because we know that it has been formed by the extended lines meeting, which cannot be formed on the screen. The image is laterally inverted. Now let us see about the image formation in the plane mirror. The lines which I am highlighting with the yellow highlighter are actually the incident rays. These are the incident rays. The lines which I am highlighting with a green color are the reflected rays. So these reflected rays are reaching to your eye. But if you extend these further in this direction, they will never meet. But if you extend backward just like this, They will meet at a point. This point will be known as the image formation point. And the distance between mirror and image, that is represented by D, is equal to the distance between object and mirror, that is again represented by D. And the pair of the line OA and AC, let us name as C. The angle of incidence 1 will be angle of reflection 1. Similar is the case with the second one, that angle of reflection is equal to the angle of incidence. In this image B, you can see the lateral inversion by the plane mirror. Let us discuss about the uses of plane mirror. So, plane mirrors are used as looking mirrors and dressing mirrors. They are used in hair cutting salons also to show a person the backside of his head. Plane mirrors are used in showcase displaying jewelry also, watches, mobile phones and other fancy items. Now they are also used in solar cookers. These are used to harness the solar energy, that is a form of green energy, to reflect the sun rays into the interior of the cookers. A plane mirror is fitted in the optician's room on the wall in front of the person whose eyesight is being tested, and optician chart is fitted on the wall behind the person. In this way, the effective length of the room or effective distance of the chart from the person's eye is doubled. Let me show you this with the help of an example. Suppose this is the person and here is the wall on which mirror is there, and the chart is kept here. Chart on which alphabets are written of different sizes to check the eyesight of the person. So what will happen? Let's say the distance of this chart from the wall on which mirror is there is D. Therefore, it will form the chart here also on the distance of D. Now what will happen? The person is asked to look at this one, this image, and then read. So what happened? The effective distance increased. Otherwise, if the mirror had not been there, if the mirror would not have been there, then what would have happened? Now let's discuss some important instruments, that is periscope and kaleidoscope. So these both are optical instruments, or you can say optical devices. Periscope is used in submarines because it helps to see objects situated above the water surface. How is this possible? So it is of something like this. Here it is your eye and here you want to see. How will you see? The light will not travel in this direction on its own. No. You have to fit the mirror at particular angle so that light strikes on this, it gets reflected in this direction. Again it will pass in this direction. If the mirror will not be there, again fit the mirror here. What will happen? Again reflection will take place and it will reach to your eye. And this instrument is used to produce colorful patterns. It utilizes the principle of multiple images of an object formed by the inclined mirrors. Now let's discuss about the speed of light. We know that the speed of light is fastest in vacuum, or you can say air, and the speed is 3 into 10 raised to the power 8 meter per second, or you can say 3 lakh kilometer in 1 second. This form which I have written just here, this is known as scientific notation. In scientific notation, large numbers are represented in a short form. The speed of the light in air is represented by the letter C, and in other mediums the speed of light is always less. In general, you can say that the speed of light is highest in air, then in water, then in the solid. Now let's discuss that in vacuum as well as air, You can take the example of vacuum as well as air. Light travels a distance of 3 lakh kilometer in 1 second. 3 lakh means distance and 1 second means time. Speed is represented by distance upon time. It will be 3 lakh kilometer in 1 second. So it will be represented by 3 lakh kilometer per second, or in scientific notation 3 into 10 raised to the power 8 meter per second, which is represented by c. So the speed of light in air as well as vacuum is a universal constant. This C actually means the constant and does not change under any condition. In transparent mediums such as water, glass, etc., the speed of light is less than its value in air, and its actual value depends on the nature of the medium. And the speed of light is minimum in diamond because diamond is the hardest substance, and the density of the diamond particles is very high, means the molecules are very closely packed, so it gives less passage to the movement of the light. If you can see here that the speed of light in vacuum is 3 into 10 raised to the power 8, and in water, alcohol, glass and diamond, all these speeds are less in comparison to air, and in diamond it is minimum. I hope it is clear to you. Thank you.